Here we are taking a look at how we can solve some equations literally. Okay, so some examples to kind of judge on. Okay, notice that as we look at these left to right sides, pretty much everything's the same except there's an extra variable on the right side. So to solve number 1, right, we take a look at what happened to x. So normally x would be multiplied by 3. Then we'd add 2 and divide by 5. So we go in reverse order and do the opposite. So we start with 5, but instead of dividing, we multiply. And we do that to both sides, giving us 3x plus 2 equals 35. Then we subtract by 2 on both sides, because that was the next step, giving us 3x equals 33. Then we finally divide by 3, and we get x equals 11. If we look at number 2, we do the same exact process. We start by timesing by 5 on both sides, giving us 3x plus 2y equals 35. Then instead of subtracting by 2, we're going to subtract by 2y. And because of the properties of equality, they tell us we can do anything as long as we do it to both sides. We subtract that by negative 2y, giving us 3x equals, now 35 and negative 2y aren't the same thing. 35 is a constant. I can only combine it with other constants. The negative 2 in the 2y actually represents us subtracting y twice, that repeated subtraction essentially. Okay, so I just rewrite them. Then we can divide everything by 3, and we get x equals 35 minus 2y over 3. Okay, now it's an ugly answer, but that's what we got to do to get x by itself. Okay, so if we look at number 3, start out by adding 5. So I get 4x divided by 3 equals 16. It times both sides by 3, and I get 4x equals 48. Divide by 4, and we get x equals 12. Okay, same process. I'm going to add 5y to both sides, but instead of 16y, we simply get 11 plus 5y, because I can't combine them. That equals 4x divided by 3, so I times by 3 the whole side. So I get 4x equals, distribute, 33, because 3 times 11 is 33. 3 times 5 is 15, so 33 plus 15y. Then we divide by 4. We get x equals 33 plus 15y over 4. Okay, again, a much more complex answer, but we just keep going step by step to get to that x by itself. Okay, on number 5, we've got 2/5 times x plus 3 equals 6. So, if I want to, I can times by 5 and divide by 2, or times by the reciprocal, which is the same thing. 5's cancels, 2's cancel, x plus 3 equals 5 times 6 is 30, divided by 2 is 15. Subtract 3, and we get x equals 12. For number 6, we started out the same way. Those cross cancel because they undo each other. End up with x plus y equals 15 again. Subtract y, and we get x equals 15 minus y. Okay, and then finally on 7 and 8, okay, I want to distribute that 2 first and get 6x plus 8 equals 4x plus 12, which is the same thing I do for number 8, and get 6x plus 8y equals 4x plus 12y. Then I want to subtract 8 from both sides. Okay, 12 minus 8 gives me 4. And then I'm going to subtract 4x from both sides, and that gives me 2x, divide by 2, and x equals 2. I can do the same thing here, subtract by 8y, and I get 4y, subtract by 4x, and I get 2x, divide by 2, and I get x equals 2y. Okay, so on the right side, we're dealing more like with literal equations, equations that we don't have quite the same ability to get it down to one answer. And we really see some literal equations when we're dealing with this. Okay? So, what's the process we would use here? Okay, well, the best way to think through that process is to look and see what we've got going on to x. So first, okay, if we had x, we would times by a. Then we would add the b following order of operations, get the top, then divide it by c, and then we'd subtract d. Okay, so to solve, we go in reverse order and do the opposite. So first, we would add d to both sides, and I'll kind of show you what that would look like. Would give us this. Okay, second step, I would times by c, because that would get rid of the c on the fraction. I'm going to have to distribute it, so I get ax plus b equals e times c plus d times c. Next step, I would subtract b from both sides, giving us ax equals ec plus dc minus b. And finally, we divide by a, so divide everything by a, and that's my answer. Okay, and that's the step-by-step process we had to do. Okay, and we know to do these because we go in reverse order, and because that's how we undo what's been done to x. So 10, same idea. Okay, same idea here. So let's take this and rewrite it. Okay. Again, what's happened to x? Well, first we would, if we knew what x was, right, we'd first times by m, get the top here, then divide by n, get that, add s, get the whole thing, divide, or take the square root of that, not divide, and then once we got the square root of it, we times it by r, and that would be equal to t. So again, we times by m first, then divide by n, and we would add s, take the square root of it, and then times by r. So for solving, we go in reverse order and do the opposite because that's how we remove it from the x side and get it over to the t side. So divide by r first. Square root of mx over n plus s equals t over r. Opposite or inverse of square root is a square, so I square everything. And that undoes that, so I'm left with mx over n plus s equals t over r squared. Then we would subtract s to get rid of the plus s. So mx over n equals t over r squared minus s. Then we times by n. So all of this gets multiplied by n. So I can leave it that way, or I could try to distribute it. Would look like that. Then that last step is dividing by m, and then we end up with our really ugly opposite side, and it looks like that. Okay? Alright, and that's kind of dealing with those literal equations.